we have this figure in the question, and it is given that if LM is parallel to CB and LN is parallel to CD, we need to prove AM upon AB is equals to AN upon AD. Before I start the question, I need to look at the proof situation here. AM upon AB. So this is AM and this is AB, and this is AN and this is AD. We need to prove this ratio are equal. Now, with this ratio, with these lines, I should be reminded by the similarity criteria of the triangle. This question makes people to fall for the BPT theorem, basic proportionality theorem, but actually it is a part of similarity conditions. Before I start this question, I'm going to explain a little bit about the similarity condition, and it's like this. If I have two triangles and I prove that any two angles of these triangle are equal. I need to prove any two angles. If I can prove any two angles of these two triangles are equal, then what we're going to say, we will say that these triangles are similar, and this is the sign for the similar triangle. Now if I can prove any two angles are equal, then we will say these triangles are similar, and by the criteria of the similarity we will say the sides are in same ratio. That's the point. So we're using this point in this question, and now I should start the question that in triangle we are using two triangles. Firstly, in triangle AML and triangle ABC. Let's look at the triangles AML and ABC. So these are the two triangles I'm taking right now, this small one, then this big one on the upper side of this figure. So in triangle AML and a triangle ABC, in these triangles I say angle A is common in both of them. This angle A is common in both the triangles, and I'm going to write the names that LAM is equals to CAB, or I can say BAC. They're both the same, so I'm writing CAB. So these two angles are equal, and the reason for that is common. This angle is common in both the triangles. Now I say that these I've proved the one angle are equal. Now I need to prove the second one. We're using the given condition right now. Now we have LM is parallel to CB. We have these lines LM and parallel to CB or BC. If these two lines are parallel, then now we should remind that if two lines are parallel, then there are three types of angle that is created. Now the first one is corresponding, then second is alternate, then third is co-interior. Now we are using the corresponding angles. This LM and BC, if they are parallel, then this angle M and this angle B, they should be equal as they are corresponding angles. So I'm writing angle AML is equals to angle ABC, and the reason for that is corresponding angle. Now I should specify the name of the lines for these. They are the corresponding angle. The corresponding angle of LM and CB, and now we have known they are parallel lines. So this is the reason corresponding angle of LM and CB. Now I've shown the two triangles. I've shown that the two angles are equal. If those two angles are equal, then I can say the triangle which I've taken before AML and triangle ABC, they are both similar, and this is the symbol for the similar triangle. Now these two triangles are similar. Now names for these is very important, as I'm going to use the name right now. If these two triangles are similar, what I'm going to do is the ratio of their sides are also proportionate. So I'm going to use like this AM upon AB, the first two of the both names of the triangle. I'm dividing this like this, AM upon AB, that is equals to AL upon AC. Now there are the third side also, but I'm actually not going to take it because I don't actually need it, as I have the first part of the proof. Now I just need the second part also. So I'm repeating this again. I'm not writing the third side as we don't actually need it right now. So I'm giving this equation 1. Now we need to look at the second two triangles. Now what we are going to do is we are looking at the lower part of the figure, and we have ANL, then we have ADC. We are using these triangles. Now in triangle ANL and triangle ADC. So these are the names of the triangle ANL and ADC. These two triangles are also similar. We're just going to prove it very soon. Very quickly we are going to prove it like this. Again, now this angle is common in both the triangles ANL and ADC. Both triangles have this angle. So we're writing like this: NAL is equals to angle DAC, as they are the same and common between them. Common. Now the second part, again we are using this line, given part. Obviously we are going to use the given part also. Now we have LN is parallel to CD. If LN is parallel to this line CD, then definitely these two angles are equal, as they are corresponding angles. Angle N and angle D, they are equal. Now I'm writing the full names to avoid any confusion in the question, and you should always write the full names of the angles. Now angle ANL, this is equals to angle ADC, angle A, D and C. Now ANL is equals to angle ADC. If these two are equal, the reason for that is corresponding angle. Again, they are corresponding angle. Now again I'm going to specify the name of the lines. Corresponding angle of line LN and CD. Okay, good. Now these two angles are equal. What I'm going to do now, if two angles are equal, then the triangles are similar. So triangle ANL is similar to triangle ADC. They are similar. ANL is similar to ADC. Now if they are similar, I'm again going to use this ratios are also in proportion, similarity criteria. So we are going to use the first two of the both, and we have AN upon AD, which is equals to AL upon AC. AL upon AC. Now again there are the third side also, but I'm not going to write it as we don't actually need it. So I'm writing this name as second one. Now we in the first one, in the second one, we see that AM upon AB is equals to AL upon AC, and again AL upon AC is also equals to AN upon AD. They are both the same. So what I'm going to do is hide this part, and I'm going to say they are equal, as they are both equal to AL upon AC and AL upon AC. So from 1 and 2, what we have is AM upon AB is equals to AL upon AC, and this is equals to AN upon AD. Now I can remove the middle part, and we get the what we need to prove. AN upon AB is equals to AN upon AD, which is actually what we needed to prove in the question. So I hope you like the video, and thank you for providing me this opportunity, Vedantu. I hope you like it. Thank you.